2 in our triangle formulae tutorials. So video 1 was about introducing the sine rule and how to calculate sides using the sine rule. In this video we're going to have a look at how to calculate angles using the sine rule. So we're still using the same basic formula here. The letters of course are dependent on the letters we write around the triangle, and lowercase letters mean the lengths of sides, capital letters mean the sizes of the angles at those vertices. So let's have a look at first example. It says calculate the size of angle ABC. So first of all we've got to make sure that we remember that when naming angles, A, B and C means it's the angle at vertex B. So that's this one here. We're looking at this angle here. We don't know what it is, we'll just call it capital B for just now. But we can see that we've got our triangle here, and as we did with the last examples, we want to label our sides. So small a is the side opposite capital A, so we can label that A. Small b is opposite capital B, so we've got that there. Small c, the side opposite angle C. And we can write out the sine rule in terms of A, B and C. So we've got A over the sine of A is equal to B over the sine of angle B equals C over the sine of angle C. So I'm not sure quite what's happening with my pen at the moment, so bear with me. What did we do here? We want to put a circle around the thing that we're looking for. We want to find angle B, so that's here. We have to keep the sign with it, so we're wanting to find that, and we can tick the things that we know. We know angle A, so we can tick sine A here. We know side B, and we know side A, which is good. That's what we want. We've got a circle and 3 ticks. We don't have any information about the fraction concerning C, so we can discard that and we can go ahead and substitute in for those 4 values. So we end up with 19 over the sine of 120 degrees. Whoops, 120 is equal to, small b is 7 divided by the sine of, we don't know what b is, so we keep that as b. You could put a letter in, like x for the angle, but we'll just keep it as capital B just now. So it's time for cross multiplying, but so we could cross multiply the whole thing. With the angles we tended not to, because we were just bringing the, we could bring one of the angles up to the other side. But I think in this case we're going to do it because the thing we're looking for is on the bottom of the fraction. So I'm going to completely cross multiply. So you've got 19 times the sine of B is equal to 7 multiplied by the sine of 120. Okay, we can see that we want to keep sine B, so the 19 is multiplying on the left hand side. So on the other side it will divide, or you divide both sides by 19 depending on how you do your algebra, over, there we go. At this point we can work out this value on the right hand side. We can't get rid of the sine just yet, we'll do that at the next step. Just like with right angled trigonometry, we could take our calculator and work out 7 multiplied by the sine of 120. 7. Now make sure your calculator is in degrees mode. I can see mine's not, so I'm going to just have to try and change it if I can work out. There we go, just bear with me. There we go. So 7 multiplied by the sine of 120 divided by 19 gives me 0.319. If you round your answer to at least 3 decimal places, 0.319, you try it yourself. And what we want then is we want the angle B, of course, so you don't have to write this step out, but I'm going to do it. We want to do the inverse sign. We want to shift sign effectively this number here. You can write it out like that in full, or you can just jump straight to the answer. Take your calculator and you do second function or shift sign to get the inverse kind of function, 0.319, and we get 18.602. 18.60, we'll round it to 18.6 degrees to 1 decimal place. We generally tend to round angles to 1 decimal place. Okay, now I've got capital B. Is that because I've used B in my formula here? It asks to calculate the size of angle ABC. So just to be correct, I'll answer using the wording of the question. Angle ABC is equal to 18.6 degrees. It's always good to go back and think, have I answered the question, particularly using the language that it asked. Okay, let's try this example here. It says calculate the sizes of the unmarked angles in triangle CDE. So in this triangle here, we've only got one marked angle. We don't know the other two. We're asked to calculate them both. So how do we start this off? Well, we'll have a look at the triangle. We've got vertices C, D and E. So we can mark in our small sides C, the small d and small e. I would write out the sine rule and we'll see what it is we can actually work out. So we write it out in terms of C, D and E. So C over sine C equals D over sine D equals small e over sine capital E. Okay, so rather than circle something that we know we need to find, let's have a look at what we've got first of all. So we've got small c and we've got small d sides, okay, and we've got angle capital C. So we know from our use of the sine rule that we need 3 ticks in a circle. So we've got a matching pair of ticks here, we've got 1 tick here. The only thing we can actually work out is going to be the angle D. We can't work out the angle at E even if we wanted to. We don't have enough information. So that's going to mean we're going to have to work that out later. So let's substitute in what we know here. So side C is 5.2 centimeters divided by the sine of angle C, which is 57 degrees, is equal to side D, which is 5.9 divided by the sine of D. D is what we're trying to find, so we'll just keep that as D. We'll cross multiply as we did in the last example. So we'll do 5.2 multiplied by sine D is equal to, and then 5.9 multiplied by sine of 57, and then we can remove the 5.2. We can divide both sides by 5.2 or take 5.2 over to the other side, depending on what works for you, and we end up with 5.9 sine 57 over 5.2, which we work out with the calculator. We've still got sine D on the left. If I do that, I end up with 5.9 multiplied by the sine of 57 divided by 5.2. I get 0.9515, so I'm going to round that to 0.952. At least 3 decimal places for the sine of an angle. So to get D, we're doing inverse sine, shift sine, and we do that inverse sine 0.952, and we get 72.17, 72.2 degrees. Now it stands to reason if that's 72.2 degrees, we don't need to run the sine rule again. We could technically this time use the sine rule. I think, or maybe we couldn't even, because we don't know the side opposite E. But of course we know the other one of the other key properties of the triangle. 3 angles add up to 180, so we can say that 57 plus 17, oh, not 172, that was me trying to draw a line, plus 72.2 degrees is equal to 129.2 degrees. What's the supplement of 129.2? That would be angle E. That's going to be 50.8. Okay. Now the unmarked angles. Let's finish it off with a bit of a flourish and not just call them capital D and capital E. So we can say that angle CDE, close that, equals 72.2 degrees, and angle, what's the one at ECED, equals 50.8 degrees, and there is my answer. Okay, so that's how we use the sine rule to calculate angles. I hope that's useful. Go away and practice it a little bit now.